So it's 8.1, but all we're doing is the systems of equations. We will do everything else later. So we're going to do Gauss-Jordan elimination. This is the second time you've done this. The numbers are going to get more difficult to deal with. The equations are going to get a little bit more, you have to think about them. The only way that you are going to do well is if you do it every day. You have a worksheet today is full of 2x2s. The whole thing is 2x2s. I think there's 20 of them. 2x2s should go quick. Do them. Even if you get stuck in the middle and you go to the next one, do every single problem. Because nothing is going to improve until you figure it out. Like the light bulb goes on, and I can't make it go on just by examples. Does that make sense? I think you will all come back to you soon. You don't need to write this. This is just so we can remember. Gaussian elimination. This is where we want row echelon form, and we actually will do reduced row echelon form, and we have X, Y, Z. Gaussian is the guy who came up with the process. Whoa. He actually is saving you a lot of work. He's the one that came up with the process. We will take systems that look like this. We will put them into matrices, and we will go from there. Hopefully I opened the right one. If not, I can just do the examples. Okay, so you can interchange the three things you can do. You can interchange two rows. You can multiply one equation or both by a non-zero constant. Non-zero. I always get people, I say, how do we get zero here? Let's multiply it by zero. Oh no, you can't do that. And then you can add a multiple of one equation to the other. And replace the ladder. Remember, the ladder means the second one. Coming back to you a little bit. I'm really having a feeling that I opened the wrong one. We'll make it work. So you are going to take an augmented matrix. What is over here in the augmented matrix? Does anybody remember? What goes in this side? The coefficients. What goes in this side? I don't know why it's the solution. You guys cannot tell me you don't remember any of this.
I remember the diagonal ones.
Okay, so we have the X column, the Y column, the Z column. We're going to do all of these operations, and we're going to leave it in reduced row echelon form. Ones and zeros. Augmented matrix just means you take it out of the system and put it into a matrix. Coefficients on the left, solutions on the right. Reduced row echelon form. Okay, so this is row echelon. I touched it. So this is row. This thing's really jumpy today. This is row echelon form. where we have X, Y, Z and not zeros everywhere. Reduced row echelon form is the ones on the main diagonal and zeros everywhere else. If we stop at row echelon form, you'd have to plug Z into Y and then plug Y and Z into X to solve it. This way we're done. We have X, Y, Z all when we're done. Okay, when we do these, you have ordered triples. We will perform on a 2x2 today. When you have a 2x2, guys, you are not going to do Gauss-Jordan elimination in general. You're going to do elimination or substitution. You're not going to do this procedure. But today, to remind us and to get us back into doing it, working with 2x2s is quicker. Okay, so we have ordered triples. So that would be one unique solution. You can have infinitely many solutions, or you can have no solution. So just the pictures on the bottom, I don't know if you need to write them, but those are pictures of how they would look, because it is a three-dimensional plane because we have three variables. So the first picture shows them all intersecting at one point. So that one point is the solution. This solution is one line. Well, would one line be infinitely many? How many points are on a line?
A bunch.
On a line, how many points are on it? Infinitely many, right? So this, where it's hitting every point here, would be infinitely many. If it is one thing, if it's all the same, again, obviously it would be infinitely many. The last two are pictures of none. This first one, we have different lines, but is there a line where they all three meet? No, so it's no solution. The last one, they're parallel planes. So if they're parallel planes, they never overlap at all, and obviously they would be no solution. So if you were to draw them in three dimensionals, that's what it would look like. So you will have one unique solution, infinitely many solutions, or no solutions. Tell me when I'm good. And no solution, we call them inconsistent. Am I good? Ainsley? Okay. Well, we talked about the main diagonal. That's just an introduction. Okay, again, you don't really need to write this down. This is a review, okay? We name them by rows and columns. So, the order, the size, the dimension are all the same. This one has one row, one column. So 1 by 1. This B, how many rows do I have? One row. How many columns do I have? 4. What about C? 2 rows, 2 columns. D?
3 rows, 2 columns.
3 rows, 2 columns. So it's row, column. I definitely opened the wrong one. But if you're asked for row size or dimensions, it's all the same thing. Am I good? Ainsley?
Yeah.
Okay. Okay, what I said already, we have coefficients are full of coefficients, augmented have the coefficients here and the solutions here. That's all it is. So, okay. So, what is happening? Well, we're going to put it, but I want to know what they did. So they put their system into an equation, yes? Okay. So how did I get from here to here? What happened?
They added the top row to the second row.
So they did row 1 plus row 2. Yes? Remember doing that now? And row 2 is the one that changed? So how did I get from here to here?
They did it again. But row 2 to row 3.
No.
Row 3.
What?
Row 1 and row 3.
Well, they got this to be a 0 from a 2. So what did they have to do to row 1 to get the 2 to be a 0?
Multiply by 2.
So if you multiply row 1 by 2, you get 2 plus 2, and that's what? You're getting closer. Not just 2, but a negative 2. So it was negative 2 R1 plus R2. Remember, it's what did you do, not what you're going to do, right? Could I have done these 2 steps in one step? Yes, because I would have, because you're not using row 1 to change row 2 and row 3, right? You're not changing. Okay, so how did I get from here to here? There's a lot of mess up there.
Negative 2 R2 plus R3.
So you think we did negative 2 R2 plus R3? Okay, so remember you're looking at this one. If I did negative 2 R2, that gives me negative 2 minus 1, which would not be 0.
You
Negative 1.
added the second row to the third.
We just added the second row to the third row. That's it. Because one's 1 and one's negative 1 already, right? Okay. So then how'd they get from here to here?
Row 2 subtracted 3.
Row 2 minus row 3. So row 2 minus row 3. So it'd be 0, 0. 1 minus 0 would be 1. Correct? 3 minus 2 would be 1. And 5 minus 4 would be 1. So is that what they did?
No.
Nope.
Multiply by 2 on row 3.
Multiplied by 3 by what?
I mean,
No, they did. Because we don't divide. Never said divide anything, right? We don't divide. We multiply by the reciprocal. So what was row 3 multiplied by? It's the only thing you can multiply 2 by to get a 1. Half. So 1/2 R3. So we will do the process of zeroing these out, zeroing this out, reducing if we can, and then going back up. Remember the 1, 2, 3, 4 process? That's what we're going to be doing. 1, 2, 3, 4 every time. If you guys try to venture off of that, because I know some of you did last year, it makes this absolutely horrible. Because sometimes it works great. You're like, boom, I'm done. But the next time I've done 5 steps and you've done 16 because you keep running in circles. Okay? So we're going to try to learn to be efficient at it, right? Okay, which one of these are in reduced row echelon form?
A.
Okay, actually, these are just row echelon form. Sorry. A is in row echelon form. Now, why is it not in reduced row echelon form?
Because there's still
These would all need to be what?
zeros.
Zeros. Okay. What about C?
No.
Yes.
How?
Okay. Is it a square matrix like every row as you go down, like there's 1, 2, 3, 4, 5 columns, yes? How many rows are there? 4. Are we going to have an issue with going down exactly like that?
Yes.
Yes. That's as close as they could get with a row echelon form. Does that make sense? Like if you can't get it to be perfect, you got to get as close as you can get it. What about B?
No.
No, because we have a what?
A row of zeros.
These two need to be switched, right? The row of zeros always has to be at the end, at the bottom. What about D?
Yes.
Yep. What about F?
What?
Yes.
Yes. What about E?
No.
No, because of the 2. Okay. Now here's reduced row echelon form, Gauss-Jordan elimination. Gaussian did just row echelon, and Jordan came in and said, "Hey, if we go down making zeros, why can't we go up and be done?" He improved it. Gaussian wasn't bitter. Cadence. Okay. So let's do it.
I am.
Ready?
Rather means
I'm just never getting this over with.
So I have 2x plus 6y equals 16. 2x plus 3y equals 7. I think you could pout a little bit better. Again, it is not practical. If I was going to do this, I would do elimination. I'd multiply the bottom one by a negative, wouldn't you?
I don't know.
Wouldn't you multiply the bottom equation by a negative and get rid of the x's?
Yeah.
sure.
I would. But,
Probably have the 3 lines.
okay, so we have to put this in an augmented matrix. So I have 2,
6.
2, 6, 3. Make sure your augmented lines are augmented lines, not dashes, not... Whose phone is not on silent?
Is it yours?
No, mine's on silent.
It's probably mine.
I think it would.
I don't know if that's true or not.
No, mine is on silent. Somebody's is...
Wait, why are there 6 yeah.
Because it's just a dotted line. You can put 2, you can put 3, you can just put a dotted line, but I cannot put 1.
I'm gonna put 1.
Why?
Huh?
Why can't I put 1?
It looks like you're multiplying.
Looks like you're multiplying. Okay, so remember all these things have to line up going down. Remember doing that? So our goal is to get it to be 1, 0, 0, 1. Yes?
Yes.
And then we'll have x, y.
Yes.
So what do you want to do first?
Subtract row 3 from row 2 from row 1.
So R1 minus R2?
Yeah.
Is that what you're saying?
Yeah.
Okay, make sure the one that's changing is always the second one. Because that's the only one that changes. So I'm not changing the first one, so I'm going to rewrite it right away so I don't try to. So what do I get when I subtract?
0.
0.
3, 9.
Okay. Now what? What do you notice about everything in row 1 and row 2?
They're all
They're all multiple.
go into them?
3 can go into row 2. What can go into row 1?
2.
2. Do you want to take care of like 1/2 and 1/3?
Yeah.
Can I do that?
Yeah.
Because then I have to go up, and so I might as well do it now, right? So 1/2 R1, 1/3 R2. So 1, 3, 8, and 0, 1, 3. So I've got my 0. I've got a 1. Now I need to come and get a 0 here. See how I went in kind of a circle? So now what are you going to do to get this 3? Remember, do you guys remember the trick of if it's in the second column, you use the second row? Okay. Whatever column it is, try to use that row to get rid of it. It helps. So we need to get rid of that 3. So what does the 1 need to be to get rid of the 3?
2 R2 minus R1.
3.
3. But it needs to be a negative 3. Yes?
Yeah.
Negative 3 R2 plus R1. Did you get 1, 0, negative 1? Hopefully you did it with me. Matthew? Oh, you're not tipping your chair. You're tipping the chair next to you. Okay, so my answer is negative 1, 3.
And there's not no easier way to solve it for that. We gotta do this.
Well, there is, like I just said, if normally I would just say negative this, so it'd be 2x plus 6y equals 16, negative 2x minus 3y equals negative 7.
Plus 3y.
So I would have 3y equals 9, so y equals 3. And I'd put it back in, so 2x.
9y equals 9.
No,
It's plus 3y.
no, it's minus.
Oh.
So 2x plus 18 equals 16. So 2x equals negative 2. So x equals negative 1. So negative 1 and 3. Okay? With two equations, you're not going to use this. This is not practical to use. But we're starting with it so we can get in the routine of
For
things.
the bigger one.
When the bigger ones, this is the best way to do it. This is actually the program. If you would look at a program that solves systems of equations, this is what they do. They put it into a matrix, and it's designed to go through this process and do it. Okay, so first thing I'm going to do on the next one is what? Write it in a what?
Equation.
Augmented matrix? I'm going to highly suggest to you, after you write your augmented matrix, before you move on, stop and make sure you put everything in correctly. Cannot stress how many times I've had somebody come in and like so frustrated because I couldn't get half of their problems to work out. And the first thing I do is I look at it and they're like, no, it's written down right. Nope, that's a negative. Or that's a positive. Okay, so here's our goal. Yes?
Do something with row 1 and column.
Well, what do you want to do?
That's the thing.
Do
I don't know.
something that we
Multiply
did
by
look
1/5
like
to get them all at once.
The first row is divisible by 5, yes? So why wouldn't I take it by 1/5?
Okay.
Now, if it was just a 2 or whatever, I probably wouldn't do it, but 1/5 will make my life easier, right? So 1/5 R1. Make sure you're lining up your matrices as you come down. Now, our goal, we're going to do, when we do this 1, 0, 1, 0, we go down, over, up, and then back if we need to. We just do in this circle. So our goal is to get this to be a 0 right here. It's in column 1, so I need to use row 1.
2R1 plus R2.
Okay, so 2R1 plus R2. So rewrite R1 so you don't try to mess with it, because you will. And what do you get?
0. -5.
Now what?
You take that row by 1/5, negative 1/5,
And why did you choose a negative, Bladen?
because it'll make that 5 a positive one.
And it needs to be positive when we're done, right?
Yeah.
And there's no point of changing something that doesn't get you closer to your goal. Does that make sense what I'm saying to you? Somebody will like, I'm going to take 1/2 of it. Well, it's divisible by 8, so why wouldn't you do 1/8? Does that make sense what I'm trying to get to? Now, it does go to your goal if you're making your numbers smaller, because if they're smaller, will you make less mistakes? Yes. Remember, this spot over here is all for that extra math, right, that you need? Okay, now what?
We gotta get that -1.
We got to get this -1, so that's in column 2, so I'm going to...
R2 to
R2 plus R1. And the whole reason you do the row to column type of thing is once you have zeros, you can't change things. If you're adding weird rows together, you're going to add back in things you just got rid of. Is that what you want to do? No. So my answer is -2,
-1.
-2, -1. And I could check it by plugging it back into the original, right? So -2, -1, so that'd be 4 plus 3 is 7. -10. -10 plus 5 would be -5, correct? Yes.
Yep.
Okay. Well, I don't want to deal with decimals, do you?
Skip the problem.
So how can I fix that?
Add them
Multiply
all over twice.
everything by 100.
I can multiply every single thing in both by 100, right?
Yep.
So 100 R1 and 100 R2. So that would give me 1, -2, -3, 6, 5, -10. Now would it be that hard to do? So do it. Did you get 0, 0, 0? And you can't do anything else, can you? Can I get this 3 to be a 0? When I have all zeros, can I get it to be a 0? So have I accomplished what I needed? Okay. What's my answer?
No answer. No solutions.
2.
Infinitely many. Because does 0 equal 0 every single time? Yes. No solution would look like this. Because this would be 0 equaled 5, right? So this would be no solution. Okay, so when we have a no, quit looking at that. I know you're looking at them fractions. Okay. When, guys, aren't decimals fractions?
Yes.
Yes. So if you don't like the fraction, multiply it by the least common denominator, yes? Get rid of it.
There's fractions.
Okay. When something is infinitely many, you cannot just stop. When it is infinitely many, you write infinitely many. And this one itself is x and y, yes? So then you name y some other variable, and we're using a. So you name y a. Because you have to have a way to have an ordered pair. Because this is like where all the planes intersected at that one line, right? Okay. So now, if y equals a, we have x minus 3y equals 5, yes? But what is y?
Right.
A. So we have x minus 3a equals 5. So what does x equal?
5 plus 3a.
So x equals 3a plus 5. So our ordered pair is 3a plus 5, comma a. So that means if I say a is 1, what's my ordered pair?
7 and 1.
How about 8 and 1?
8 and 1.
Okay. If I say a is 2, what's my ordered pair?
11 and 2.
Makes sense what happens?
Yep.
Okay. So if it's infinitely many, you can't just stop. I don't think my next one is fractions, but let me look. Nope. Oh, what do you have to do? We're not going to do this problem, but what do I need to do with it? What's wrong with how this is written right now? The x, y, z have to line up, yes? So when I write it in a matrix, this would have to be my negative x plus 3y. When I write it on my paper, I would move things over. I wouldn't put it like that, okay? If they're out of order, you need to get them in order.
So if there is like on that one,
Oh, sorry. Yes?
if there's no z, so we can just put a 0 for it?
Yes. You would put it as 0. In order to get one unique solution, if I have 3 variables, I have to have three equations. So this problem right here is either going to be no solution or infinitely many solutions. Because I cannot have one solution unless I have matching equations with variables. Does that make sense? What I wanted to, before I let you go, because you did see fractions on there, yes? Okay. Somebody give me one of the ones with fractions.
1 minus, it's negative 7 equals 7 plus 10x.
Negative 7 equals,
7 plus 10x.
no.
No, because that's what it is.
Yeah.
There's not a y in
It's
there?
Negative 7y.
It's negative 7y. Thank
7
you.
Plus 10x.
And then 0 equals 1 minus 5 over 17y.
Okay, say it again.
0 equals 1 minus 5 over 17y minus 4 over 17x.
Okay, you cannot work on that. You can do this first step on there because we're not going to do it all, but do not have enough room to work on this worksheet, do you?
No.
No. Remember, I have scratch paper over there if you don't want lines. If you want to free your brain from the lines. But fold your paper in half, go down, make your columns. Okay, what do I need to do with this?
You need to set it up correctly.
I need to set it up. It needs to be X, Y, and equals on the other side, yes?
-7 minus 10x equals 7. 7.
Actually, I'm going to move this over here.
Yeah, -7.
So negative 10 minus 7 equals 7. X, Y. Always in alphabetical order. It's okay if I kind of skip the step of, like, I'm okay. Okay. So, well, I need to just move the 1 over here, don't I?
Yeah.
So it'd be negative 1. And it'd be negative 4 over 17. And negative 5 over 17. Does everyone see what just happened?
Yep.
Okay. Now, I don't want to work with 17. So what do I need to multiply?
17R2.
I need to multiply. My first step would be 17R2. Now, am I probably going to end up with some fractions in my answer?
Yeah.
Probably, but that doesn't mean I have to work with them the whole time, does it?
No.
So that would be negative 4 minus 5 minus 17. Biggest mistake is not multiplying all the way through by something. Okay, what's your next step you want to do? We need to get this column, this to be a what? 0. So what's the least common multiple of 4 and 10?
2.
Multiple.
So 40.
How about 20?
20.
You can do 40, but what's that going to do to all your numbers? Make them bigger. Okay, so one of them needs to be a negative, correct? I'm going to suggest to you, you always put the negative with the first one. Because I don't know why, but when we subtract it, make it negative in the middle, we forget to distribute the negative. And I don't know why, but it just happens. So I'm going to do negative 2 R1 plus 5 R2. So that'd be 20 minus 20. Oop, need to rewrite the first row, right? So what would I get?
0.
0.
Is that 3 or 5?
It's a 5. Because you need 20.
-6.
So you have negative 14 minus 25.
I did right.
Actually, it'd be a positive 14.
Yeah.
Positive 14, negative 25, so it'd be negative 11.
Negative 9.
No, 25 minus 14.
Oh, yeah. I was thinking of the back.
I know, I should have wrote it the other way.
That's looking at
Okay, and then negative 14 and negative, 5, 85?
Yeah.
So negative 99. Okay. Now what?
I give up. For
Remember, you want 1, 0, 1, 0, right?
R2, you could divide by -11.
You can multiply by negative 1/11.
That's what I meant.
Okay, I would only suggest doing this if it makes, like, it's an even factor, right? Don't make yourself work with fractions. We just got rid of it, right? 1/11 R2. So negative 10 minus 7. 7, 0, 1, 9. Now, you should still be able to go down. I can't. This is why you guys have paper and I don't. Okay. So now what?
Gotta get the -7.
We gotta get this -7, so it's in column 2, so I'm gonna use row 2. What do I gotta do to row 2 to make it work?
Divided by 7.
So 7R2 plus R1. So -10, right? And then 0. And 63 plus 7? 70. Do you see how I'm putting that work like out to the side over here? Don't try to hold it all in our brain. We know how much of a sieve it is. Now what?
Gotta get that -10 now.
You got to get that -10 to be a 1. How are we going to do it?
1/10.
-1/10? Why does it need to be negative?
Because it's negative.
Because it needs to be a positive 1. So it'd be 1, 0, -7?
Yeah.
0, 1, 9. And so the answer is -7, 9. Now, could you possibly have a fraction at the end?
Yes.
Yes. There is nothing that says you are not going to have fractions. How do I know if I'm right or not?
So back in.
I can plug it back in, right? So if I have -70 plus 7 would be -63. So I'm right there. So you need